Hello sir, my name is Viraj Madke. I am a second year undergraduate from the Department of Mechanical Engineering, IIT KGP. My teammates are Sunny and Eric, and together we'll be demonstrating you a project of dumper truck simulator, and we hope you like it.
Hello sir, my name is Gamit Vijaykumar, second year undergraduate student in the Department of Mechanical Engineering, enrolled in its BTech course. The topic of our project is the dumper truck simulator. Here is the diagram of the truck when everything is in rest position, and all the lengths shown in this diagram are assumed. This length is L, which is considered to be the longest length. P1 P2 is the actuator and is a link. This yellow length is an inextensible string, and P4 P5 is the gate. All the angles in this rectangle are 90 degree. Here in the second diagram, it is showing that when the truck is about to dump something, this length is L as mentioned earlier. P1 P2 is the actuator. This is angle beta. This yellow length is the inextensible string, and as mentioned earlier, this is the gate which is now open, and all the angle in this rectangle are 90 degree. So when the truck is about to dump something, the length of the actuator is increasing, and so as the angle beta is increasing. We can calculate the angle beta with the help of cosine rule. Here P4 is considered as the reference point, and its coordinates are x comma y. We can calculate the coordinates of the point pz with the help of cosine rule, which comes to be x minus L cos beta comma y plus L sin beta. And similarly, we can calculate other points using beta.
Hello sir, my name is Kumar and I am from mechanical department, and here I am going to explain the working process of the gate of our simulation. This is the picture of our simulation, and here P1 P2, that is this is the actuator. It means its length can increase, and this yellow line is the inextensible string. It means its length will remain constant, and this string is connected to this link, which have this link, and this red joint is the revolute joint. When actuator length increase, this blue part will raise up, and because this string is inextensible and this joint is revolute, this black point will move downward, and this point will move upward, because of which the gate will open. And here this black point is the magnet which have the gate to remain closed when dumper will in its original position.
Hello sir, this is Viraj. For the simulation part of the project, we used MATLAB and its packages. So as mentioned in the slide earlier, we assumed all the lengths here, and we calculated the angle beta using the cosine rule. For the code implementation, we gradually increase the length of the actuator A, which in turn increases beta. Let's see the simulation for a better understanding of what we just said. As the length of the actuator increases, the angle beta also increases, and as beta increases, the point PM will have a tendency to move in X direction, but as it is attached to a link, this black point here will also move in X direction. The black point is attached with an inextensible string to the base of the body, so it follows a downward facing path, which in turn causes this black point here to go upwards, and ultimately leading the gate to open. But in reality, the actuator is not placed on the point P2, it is placed more closely to the point PZ. But to mimic the figure given in the question, we took the actuator at the point P2 and not at point P0 as shown in the figure. As the length of the actuator is the main driving force which drives the simulation, we have to implement two for loops, one which increases the length of the actuator gradually and one which decreases it, so that the body comes to rest in a stable situation. This black point here is actually a magnetic strip which when the body comes to rest in the final position, it will stay locked. It can also be said as a locking mechanism.